Now, this illustration deals with outlets. Either we have combination loads or the same type of loads. But this is in accordance with 220.14, D is in dog, E is in Ed, and L is in love. Now, notice in the information in the illustration at the very top, we have a circuit breaker or fuse. We have a branch circuit overcurrent device at 210.20A. We size the conductors by 210.19A1A. And notice we have a continuous load of 4 amps, 10 amps, and then we have a non-continuous load of 2.5 receptacles. We have a luminaire resistive. We have luminaires that are electrical discharge. So we have combination loads here: incandescent, fluorescent, and receptacles, combination type load. Now, from this, 220.18b, it's the ballast rating that we take, not the wattage of the lamps, but the ballast rating. And then we either take the rating on the fixture. For example, if the fixture for resistive said maximum 100 amp watt lamps, that's what we could use. But if it was 75 watt lamps, you'd have to put 75, not 100. If it happened to be a 60 watt lamping, then you would have to naturally put 60. You couldn't put 75 or 100. So that's what your sections are calling out to you. Now, to calculate for conductors, we would look at 210.19A1 and 210.20A. And we'd take 4 plus 10, 4 amps plus 10 amps, which is continuous load, and increase 125% to 17.5. Then we take the 2.5 receptacle load that's non-continuous. They would not be used off the same time for 3 hours or more, as identified in Article 100 for continuous duty and operation. We come up with 2.5. Adding that up is 20 amps. Now notice, by taking the 125% for continuous and derating the breaker 80% loading and adding the non-continuous load, we could use a 20 amp device. But if you use the 80% rule, you probably couldn't use a 20. So that's what's important. So our table 310.16 would require number 12 wire on a 20 amp device, which is selected to the right. 210.19A1, the conductors come along at 125% to derate the loading of the breaker 80% in accordance with 210.20A. So we would take 14 amps, 4 amps plus 10 to give us 14 times 125%, 17.5. 2.5 times 100% for the non-continuous load, 2.5, 20 amps. So 240.4b, along with table 240.6a, would allow a 25 amp overcurrent protection device to be used on the number 12 wire calculated to the left. So what does this tell us as designers, electricians, inspectors, maintainers, whatever? That the 125% application derates the breaker to 80% loading for continuous duty. 100% of the load would be taken if the loads operate less than 3 hours. And that's what our figure 14-21 is illustrating, along with the conductor. Now it's got to come along at 125% to derate the loading of the breaker 80% and serve speak as a heat sink between the breaker and the load served to keep that heat off the breaker for continuous load plus the non-continuous load. And that's what our figure 14-21 is illustrating in 220.14D, E, and L.